So I'm going to find the tangent line at any location. So let's say we have a function like 2x squared minus 3x plus 1 on a graph. It's going to look something like this. If you put this on a graph, you'll get a graph like something like this, a parabola. Now we want to find what is the tangent line. Tangent line of, let's say, as x approaches 0, as 4, 3, 4, 2 is 8. Let's say at x approaches 2 minus, yeah, x approaches 2. So you want to find the tangent line at x approaches 2. So a tangent line is a line that's drawn like this. So what we do is, if to find the tangent line, this point here, you pick two locations on the graph. So say you have the graph like this, right? You have a graph. How do you know the point over here? You pick 2 points on the graph. This is called the right. If you pick 2 points on the graph and you find the slope of that line, y2 minus y1 over x2 minus x1, you get an answer. You get like 2. If you pick 2 closer points, the line becomes more and more straight. You get a better answer. Maybe you get like 0.5. If you pick 2 closer locations, you get a better answer, 0.02. You keep getting better and better answers as you put points, because you want to find the slope of that point of the line, so you use points better and better. So the best thing to do is to put the point exactly on the point. But when you do that, you don't get an answer, because the slope becomes 0 minus 0, draw a line, and you get or in this case, if this is 2, there will be 2 minus 2. This point would be here. If you put the points like directly, and you'll get form y2 minus y1 over x2 minus x1, which will give you 0, 0, 0, which is undetermined. So you can't. So that means that the slope of a tangent line becomes a limit problem. You can't find the slope of a tangent line to the exact, because it becomes 0 over 0. So it becomes, you can only find the limit of a tangent line. So that's what we're going to do. We're going to find the limit as x approaches 2 of this line to find what the tangent line is. So to find the slope of this tangent line, you pick a point here on the tangent line. You pick a point here. You call that point x. If this point is x, then the point next to it would be x plus delta x, because this point here is delta x. From here to here is delta x. So it will be x plus delta x, and this point we have will be x. Right? So now you find the x and y coordinates. X coordinate of x1 would be x, and x2 would be this here, x plus delta x. Y1 would be, if this is x, if the function is, you will plug x into the function, you will get 2x squared minus 3x plus 1. Y2 is, to find y2, you plug y into the equation. If this is y1, then y2 would be, you plug this whole function here. Y1 would just be this. Y1 would be wait. This would be x, and the x2 would be, right. So for y2, you just plug this function here into this. Just like you plug this into this function, you gotta plug this to find for y2. So y2 would be 2x plus delta x squared minus 3x plus delta x plus 1. You have to work this out. You'd get 2x squared plus 2x delta x plus delta x squared minus 3x minus 3 delta x plus 1. So now you work that out, I get 2x squared plus 4x delta x plus 2 delta x squared minus 3x minus 3 delta x plus 1. Right, so now you found y2. You found all the coordinates, found x2, y2, y1, y2. You found all the coordinates at this point. Now you can find the slope of that. So slope of a line is y2 minus y1 over x2 minus x1. So y2 would be this point here, and you minusing this entire thing by y1, which is minus 2x squared minus 3x plus 1. Now you gotta be careful because this has to become minus. So what this comes, we write back the equation. This becomes minus 2x squared plus 3x minus 1. Then you minus it from there. Now you can minus everything together. So plus the 2x squared minus 2x would cancel. Minus 3x plus 3x would cancel. Plus 1 minus 1 would cancel. So you're left with 4x delta x plus 2 delta x squared. Oh yeah, and all this is all over. All this is going to be all over x2 x plus delta x minus x. So the x would cancel and you get that all over delta x. Right, so now what you want to do is you want to factorize. So you can factorize the delta x. You factorize, you get delta x 4x plus 2 delta x. Delta x is oh wait, a minus 3 means 3x cancels. You left with 2x and minus 3 delta x. Oh yeah, you forgot the delta x. It's gonna be minus 3 delta x from over here. Minus 3 delta x. So when you factorize that, you factorize out, this would factorize out over delta x. The delta x and delta x would cancel. So you're left with 4x plus 2 delta x minus 3. Right, so now you can find the limit of this. Now you want to find the limit as delta x goes to 0, because delta x is going to 0. It's getting closer and closer to where there is no line. So you can find the delta x goes to 0. So, or 4, it doesn't matter. So the x goes to 0, find the limit of delta. So 4x plus 2 by 0 minus 3 is equal to 4x. So this will cancel, get minus 3. And that is the equation for finding the slope of a tangent line at any location. So the original question says find the slope of the tangent line at x goes to 2. So on the graph, what is the slope of the tangent line at x equal to at this point here? We'll just plug it in to that function. So we got 4 by 2 minus 3 is equal to 2 is 8 minus 3 is 5. So the slope of the tangent line is now it's a limit, so there is a limit as x goes to 2 would be 5. And that's the slope of the tangent line. Well, the slope of the tangent line is a limit. So you had to write it like that. There's a limit at x goes to 2, which is 5. You could find that for any location if you find it. If x goes to minus 2, then you just plug minus 2 into the equation. Tangent line would be positive. That's here. So x goes to minus 2 would be 4 minus 2 minus 3 is 4 2s are minus 8 minus 3. Minus 8 minus 3 is minus 11.